Hey, welcome everyone. Seems like a packed house today. I hope there's some gas remaining in the tank. There's a lot of cool new features that we want to discuss today. I'm Kunal Jha, Senior Product Manager at AWS, and with me I have Sean Morgan, who is Senior Machine Learning Solution Architect at AWS, and I have Chitrang Jain, who is Engineering Manager of AI/ML platforms at Intuit. And today we want to talk about how within SageMaker we have built new capabilities that provide to enhance and develop and transform the overall ML development workflow and for overall team-based collaboration. So let's get right into it. Collaboration is the norm of any workplace that exists across the world. Most of us may be working in different functions and different geographies while trying to solve multifaceted problems, have to collaborate with different groups of people to get to the final solution. Research shows that employees spend about 50% of their work week doing collaborative activities. And this is true for machine learning development also, where different personas need to interact with each other as part of the overall machine learning workflow. We find that there are different number and type of teams that participate in the overall machine learning-enabled system development. It differs widely from different company to company, community to community. Their composition, their responsibilities, the formality of their collaboration also varies very widely. And the kind of mechanisms that they use to bridge these gaps across various parts of the workflow for machine learning, they might be using like an email or different messaging applications to bridge the gaps and collaborate in different parts of the machine learning workflow between different teams, between different functions. But all of this collaboration provides tremendous benefit, but also comes at a cost. Cognitive psychologists have researched and shown that around any minor interruption requires up to a minute to get back to what you're doing before. A slightly major interruption might require up to 23 minutes to get back to what you're doing. And so ideally, you would want these collaborative activities to be kind of part of your workflow rather than switching between different applications and having switching costs as you go around it. So overall, for machine learning, in 2019, we launched SageMaker Studio, which is industry's first IDE that is built specifically for machine learning on top of JupyterLab. You can utilize this IDE to build, train, tune, debug, deploy, monitor models, and even operate machine learning ops pipelines from a single pane of glass in Studio. Today, tens of thousands of customers have adopted that vision and utilized Studio, with Intuit also being one of major utilizers of Studio to empower the data science team of all sizes. Given the amount of moving parts and capabilities that we have in terms of different teams and functions trying to come together to work on a machine learning business problem, we wanted to solve collaboration capabilities and provide these team-based sharing collaboration capabilities and feature sets right as part of that overall Studio experience. Along with collaboration, once you have these features, we also wanted to make it easy for the right set of people and applications to find and access and share the right set of resources and provide different boundaries and entities that they can utilize to do this. With this in mind, I want to kind of talk a bit more about what the overall machine learning flow might broadly look like if I had to kind of break it down into some smaller pieces. We see multiple personas in terms of, for example, a few of them could be like data scientists or data engineers, or machine learning engineers. And these personas refer to different tasks or activities that they perform as part of the overall flow. Often, this could be a single person doing all of these activities together. And these personas have to kind of frequently collaborate as they progress through the typical machine learning workflow, which might look like something like this. Like you ingest a small sample of data in the notebook, then you kind of explore, visualize the data, take the sample to kind of understand its characteristic and distribution of values, get a feel for what the data looks like. Then you probably clean, prepare, format, prepare, and extract meaningful features from the data. Then probably you would experiment with some of these combination of features, algorithms, and parameters. It's an iterative process to train different kind of model candidates. You could have thousands, up to thousands or more of different experiments that you would be running to identify a successful model candidate. Once you identify a winning model candidate, you probably want to scale your experiment by running it over a pretty large amount of data sets, or retraining the model if you have new data that you get from the source. Once this is done, you probably would kind of deploy this to production, and all of this different part of the process of a machine learning workflow requires different personas or functions working together in any large enterprise. And utilizing various external applications to kind of bridge that collaboration gap leads to hampered productivity overall. So beyond the builder personas that we are talking about here, there's also an overarching persona of platform administrators who set that whole platform up, provide everyone the right set of permissions, data sets, and accesses, and the right set of resources that they can access and actions that they can take. Now, not having the right set of accesses or proper isolation or different activities that administrators have to provide to the builders requires frequent iteration that leads to further hampered productivity. So for these different builders, we talk to large body of customers to understand what are different key challenges that they face as part of overall sharing and collaboration. So they categorize their overall ML endeavors generally into a specific business problem. They want the right set of contextual resources to be surfaced that are specific to the business problem as a whole, rather than being tied to various different business problems that they might be working on at the same time. Further, once these artifacts are created, such as models and notebooks, given that there's so many steps involved in the machine learning workflow, they want to share and collaborate with different stakeholders. They want to gather feedback and have it as a seamless part of the overall workflow. And using, as we're talking about utilizing different external applications to do that, leads to overall communication fatigue, delayed feedback loops, and version control issues broadly. And these challenges surface as part of any specific ML business problem that you're probably doing. So with this in mind, I'm super excited to announce that we launched overall real-time collaboration capabilities within SageMaker Studio. So today, utilizing SageMaker Studio, ML teams can come together and create shared spaces for data and machine learning teams to organize, share, edit, and review notebooks at the same time. Further, I would love to also key in and talk about what else they can benefit from utilizing the shared spaces beyond co-editing and co-executing in real time. What other capabilities? So as builders, I can access within these shared spaces a shared studio environment. Simultaneously, multiple builders can come together to read and edit and share their notebooks. But this also gives me a path to kind of iterate on a new idea on a shared studio environment together. Further, I can also share different files and artifacts beyond notebooks, utilizing my shared EFS, Amazon EFS or Elastic File System directory. And primarily, I would only see the problems that are relevant to me in terms of any artifacts or resources that are created specifically for that business problem. Further, any resource that you create, the service automatically tags that, and we'll see how we kind of utilize and what we gain out of that. So let's take a look at broadly how all of this kind of fits together and works. So for example, when you need to collaborate with your peers on a business problem, you create a shared space in SageMaker. As we're talking about how this shared space gives you access to a shared SageMaker Studio IDE, where you can view sample set of notebook files on a shared Elastic File System. Further, you can get together, co-edit, run, and review the notebooks together in real time. And at any point of time, you can checkpoint your code in the code repositories. And these shared spaces support Git, Bitbucket, AWS code commit repositories. And once you have all of these notebook files and resource, experiments, models, pipelines, training jobs that you've created within this shared space, they're automatically tagged by the service. And the service automatically filters these resources so that only the resources that are created within the context of shared space are visible to you and offers a decluttered and organized view specific to that business problem. So let's quickly see how all of this kind of fits together in the overall SageMaker structure. Now, as a builder, you typically have an AWS account, and within that account, there are various entities that kind of fit together. First being something called a SageMaker domain, which primarily is associated with overall EFS volume and has a list of authorized users and has different configuration and security policies and VPC configurations associated with it. Currently, I, as a person, or I, as a human user, am probably represented by a user profile under that domain. And this user profile is primarily tied to a purpose of sharing, reporting, and overall any other user-oriented features. Currently today in Studio, if I want to do solitary work, under SageMaker, I can launch my own personal Studio application, which has its own private EFS directory that no one else on that domain can see. It's just only relevant to me and only I can see. Now, you always can continue to do that for your solitary work. Now, if you want to do a collaborative work in a collaborative setting, you can create these shared spaces, which are communal IDE application with a shared EFS and with access provided to other users within the domain that you can collaborate with. Now, this neatly ties into once we have these collaboration capabilities, how do we bundle and provide these capabilities to the right set of users, to the right group of users, and to the right teams or a thematic grouping that can work. Awesome. So as this is a problem that has been a challenge for platform administrators, so slightly changing gears here. Today, administrators, we've talked to a lot of platform administrators across the different customers, and today they want a tractable mechanism to reflect their internal organizational structure within an account. They want to ensure that there are minimal overheads in providing the right set of access control to groups of users while simultaneously ensuring that resources or artifacts are isolated across these groups of users. Further, in these static macroeconomic conditions, they have highlighted that they want visibility into the cost and usage at a very granular level, be it in terms of lines of businesses or individual users or specific business problem also or projects that they want to look at. And all of these challenges that they face, they want this to be solved and taken care of by the service rather than requiring inputs from the end users or for them to do any activity to kind of support this. So with that in mind, I'm super excited to also announce that we have now the ability to create and manage multiple SageMaker domains in a region in an account. What this will enable, and we'll talk in more detail, is you can utilize this to reflect your internal organizational structure within an account, be it lines of businesses or teams. You can utilize these domains to group different set of users and reflect your org structure, and also have a more granular management of overall cost and usage at the various levels that we're talking about. Additionally, you can easily set up isolation across these different domains, utilizing various policies and utilizing the aspect that the service automatically tags any resources that are created within individual domains. So let's see how all of that fits together and works. And so as an administrator, you can create different domains in an account. You can have different security configurations, VPC configurations for it also. So for example, you can have one domain on the public internet while other is on a VPC with slightly stricter controls. Once you have these domains created, you can provide different set of access control to it in terms of setting up different execution role to which you can attach different policies. So different domains which represent different lines of businesses or teams have their own set of access to data or different actions that they can perform. Additionally, any resource that is created within the domain is automatically tagged by the service. And you can utilize these tags to easily create simple policies that ensure that resources are isolated across these domains. So if I'm a member of my own line of business or a team, only see things which are specific to me and work on things which are only specific to me rather than things which are specific to other people. And then you can create different user profiles and group them as part of these individual domains to represent your overall organizational structure. Additionally, the automatic tagging also offers an additional value where you can utilize these tags within AWS Cost Explorer and AWS Budgets to check for cost and usage at various levels, be it lines of business or teams or specific individual users, or even specific individual business problems or shared spaces. Now let's see how all of this kind of ties together. And so primarily, as part of overall SageMaker Studio Notebooks utilization, first you set up the administrator sets up their machine learning environment, the overall platform, and they can create separate environments for each business unit, configure different configurations for them, and set up with default packages and resources that they can utilize. Additionally, we have other key launches around how you can utilize different capabilities to seamlessly prepare data. And then you can easily start building on Elastic notebooks with the latest machine learning packages and prepare and use the built-in data preparation capability right within these notebooks. Once you have these notebooks kind of stood up as a user, you can organize and collaborate utilizing the features that we are discussing, and finally then deploy the notebooks in an automated manner to production. So definitely do check out different other capabilities that we have launched as part of overall next generation Amazon SageMaker Notebooks experience. So enough of telling. Let me move to the show part, and I would love to invite Sean Morgan to demonstrate all of these capabilities that we have been talking about here.
Thank you, Kunal. Today, it's my pleasure to go ahead and demonstrate these capabilities outlined by Kunal's previous slides. Just give me one moment here. OK. So today, we're going to be demonstrating 3 unique capabilities that have been added to the SageMaker domain. The first of them is the ability to create multiple domains within a region. You can do this by separating your line of businesses or certain groups of teams that need distinct configurations, whether that's, as Kunal mentioned, where some teams may have access to the public internet, and other teams may need to go through a direct VPC route and only touch certain endpoints that they're allowed to, whether that be for package repositories or code samples. A domain itself, as a bit of just kind of background here, is a collection of users as well as configurations. We can see here, I'm checking the first domain, which is our sustainability research domain, and we can see that there is 2 users attached to this domain. Myself and Sumit both have user profiles attached to the SageMaker domain, and what that enables is that gives them each a granted set of permissions. Those permissions could enable them to access certain data resources, like some S3 buckets, but not others. It could permit them to launch AWS services like Glue Sessions or SageMaker training jobs. And those permission models can be granular down to the user level, or you can share one execution role across your team. Another nice feature of SageMaker domains is that it provisions an elastic file store. So that is a network mount where you can have your own private home directory for each user when they load up the IDEs. We'll be showing this more in detail, but it's sufficient to say up until this morning, each user would have their own code and data files separated from the others. That's great if you're doing solitary work, but it's not great for collaboration, and it requires that asynchronous process of sending each other information or snapshotting notebooks and getting it sent over. And so today, I'm going to be happy to demonstrate the real-time capabilities, collaboration capabilities. Within our sustainability research organization, if I go to the Space Management tab, I'll be able to see shared spaces that we have provisioned for specific machine learning endeavors. We can see that this sustainability research organization has a project related to electricity consumption, as well as an air quality study. Those shared resources provision a SageMaker Studio IDE where multiple users can load and collaborate in real time. They also have a directory on the EFS mount so that users can share the same files, whether those are data, code samples, or repositories. This unique domain also has the ability to configure the environment of the domain, which comes down to 2 very critical features. The first one is the ability to specify custom images and kernels for your domain. You can imagine that customers may want to be able to have the ability to run, say, Scala or Julia kernels. They may just want to have a very bespoke Python environment that relates to their team, and they want it available for all of their users. A domain can have its own unique lifecycle configurations, which you can think of as startup scripts that get launched at the start of the IDE to install, say, Jupyter extensions, or it could be launched at the kernel time to install packages. Again, each domain is configured with its own configurations, which can enable different VPC or networking access, or perhaps maybe one of your team and domains has licenses for, say, RStudio on SageMaker, but not the other. And so by doing this, you can separate your line of businesses across in a single region with access to the same data by using multiple domains. For our demonstration, we're going to be looking at the financial team, which has its own unique domain in this account. You can see myself and Kunal are users of this domain. And so we're going to be loading up a collaborative space where we can edit the same code at the same time. To do this, I'm going to first look at the different spaces we have in this domain. And you can see that our specific machine learning endeavor that we want to work on together is the financial audit of 2022. By selecting my user profile, if you're a previous SageMaker Studio, you may recognize the personal apps of SageMaker Studio and Canvas. There is now a third option for collaborative spaces. After selecting a collaborative space, I can choose which space I want to launch and simply select Launch Studio as that user persona. Upon loading, I'd be greeted with this page. This is our revamped SageMaker Studio UI, which launched this morning. So if you're a SageMaker Studio user and this looks new, that is why. If I were to click the file directory on the left-hand side, you can see that the home directory of this specific space is able to have joint collaborative files. You can see here we have a number of notebooks, a Python module, a JSON file, of which we can all collaboratively edit. We've also decided to make some unique directories for our own user profiles so that we can separate code that we don't want to be collaboratively looked at the same time by putting logical barriers on the directory. We also have a shared data directory that we use throughout our notebooks. If you'll notice on the top right of the SageMaker Studio environment, you can see that I am logged in as Sean-user, and the space or the application that I'm running is the Financial Audit 2022 shared space. For our machine learning problem that we're going to analyze today, we're going to look at a common problem that we see machine learning bringing business value directly today: customer churn. If you're not familiar with customer churn, losing customers is costly for any business. For this particular financial audit workflow, we want to make an example of analyzing last year's previous model, which tried to predict whether a customer would leave the business or not. It's often cheaper for businesses to find out and grant incentives to customers that are likely to leave. And so it's important that our customer churn predictive model is accurate so that we can save costs in the long run. If I were to run this particular notebook, this simply pulls a synthetic 2022 data set, and we're going to plot the accuracy of last year's model. We can see that this model in 2022 had an area under the curve of 0.65, which is good, but not quite where our team wants it to be. In this particular hypothetical example, I'm going to be playing a bit of a subject matter expert for this telecom company, and Kunal is going to be the persona of a machine learning expert who will be improving our model. To do this, we need to build a machine learning model using last year's data so that we can accurately predict the 2023 customer churn. If I were to generate a portion of synthetic data, you could see that the data set that we're looking at has a lot of different information that we can use to build our model. It has features such as the number of minutes that they spent during the day or night on calls. It has very salient features such as the number of customer service calls, as well as other maybe less important features like the international plan or not. We don't quite know yet at this point. Lastly, we have the ground truth from 2022 about whether these customers churned or left the business or not. We'll be using that as our target label column as we go about building our model. One thing to note that's different about a SageMaker space, or a shared space in SageMaker, is that you have the ability to see who else is using the notebook at the same time. On the left panel here, you'll notice this collaborative button that you can select, and I can see who the online collaborators are. At this time, Kunal is logged in 2 different locations and is checking on the same notebook. To process this data, we're going to use this function here, which is able to use my expertise as a subject matter expertise in telecom to determine what features we want to use to build our model. In this particular situation, we're going to drop the phone number of the user, as that's not really a salient feature, and we're going to do some other data munging as a part of our processing. If I were to process this data on the last year's data, I will now have a data set which I'm going to use for my first pass at building a machine learning model. I've decided to use a random forest classifier with 10 estimators and a criterion of the Gini. I'm setting a random state of 0 so that as we go about our iterative process, we can go ahead and see, are we actually improving the model, or are we just getting different samples of the data set? we can see that the F1 score of this particular model was 0.89. If you're not familiar with the F1 score, it's the harmonic mean of the accuracy and precision, or precision and recall. And so 0.89 is a very good model. But what we want to do is we want to improve this as a team. So instead of me, saving this notebook to disk, go ahead and writing an email to Kunal or using some kind of instant messenger to send it over to him, we want to use the same notebook at the same time. As you can see, Kunal user is actively in the notebook, and I can see his cursor in real time, the orange or yellow user cursor. Kunal is going to use his machine learning expertise to copy the random forest classifier, and he's going to add it to his own cell here as he goes about adding the parameters. Kunal's doing this in real time right in front of me. This isn't a recording or anything like that. So you can see that he has increased the number of estimators based off of his knowledge of the machine learning model, and he's moved the criterion to entropy. We're keeping the same random state as we go about building the model, and we can see that Kunal has executed the cell, and I can see that he has improved our model. Kunal is now writing a comment that says, Sean, this seems much better, and I'm happy to have him in real-time collaboration without the need to asynchronously collaborate. One of the nice features that Kunal mentioned of shared spaces in SageMaker Studio is that automatically resources are tagged to this particular shared space. That means things such as experiments or models in the model registry are scoped directly for this specific ML endeavor. In this case, our financial audit of 2022. If I were to go to the new SageMaker Home tab and check experiments, I can see that the only experiments that are visible to me are the audit experiments that we've created from this particular IDE. Anywhere else in the domain, whether they're in personal apps or other spaces, would not be visible to the users within this shared space. To emphasize this, if I were to go back and launch the Sean User Personal Studio, I could go to Sean User under this particular domain and click Launch Studio. And then I would land in a very similar looking SageMaker Studio application or IDE, but you'll notice the collaborative tab is not available on the left-hand side. On the top right, you'll see that this is logged in as Sean User, and the Personal Studio is what's actually loaded, whereas previously this was the financial audit 2022 space. If I go to look at the experiments that I'm able to view as my Personal Studio account, I can see all of the different resources that have been granted to me or that I'm allowed to view. As Kunal mentioned, you can set different isolation policies so that you're only able to open resources from your own domain that can relate to, say, experiments or model registry. But in this case, I have access and can view all of these different experiments. This doesn't just apply to experiments and model registry and other tabs available in SageMaker Studio, though. It applies to any taggable resource that gets launched from the SageMaker Studio IDE. Specifically, that can also apply to, say, training jobs. So we'll see, if I look at this one particular training job in the AWS SageMaker console, I'm able to view this audit experiment that was ran from our shared space. If I jump down to the tags section, you can see that this was automatically tagged with my domain ARN, as well as the space ARN that I was using. You can see the financial audit 2022 was tagged specifically to this training job. We're going to see how this makes administrators' lives easier as they do things like cost allocation. But if I were to show you a training job that was launched from my personal Studio IDE, in this case, Sean Morgan training job, you'll notice that as of today, these training jobs are automatically tagged with not only your SageMaker domain ARN, but this time it's tagged with your user profile ARN instead of the space. This enables you to track what resources are being launched from personal Studio applications, as well as shared spaces and machine learning endeavors. If I were to look at this from a cost analysis perspective, we can see the AWS Cost Explorer for this account over the past 4 days. I've limited this to to the service of SageMaker. So all of the charges that we're seeing here are related to SageMaker. Perhaps as an administrator, I want to see exactly which spaces are running these certain costs. And I can do this by using a cost allocation tag for the SageMaker space ARN. We can see that the air quality study is running about half of the bill, as well as the financial audit is running a large portion as well, and the electricity consumption shared machine learning endeavor. It's not just spaces that do this reporting, as we had seen in the previous tagging. You can also view the domains. So if I need to allocate which of my distinct lines of business are impacting the bottom line here, I can see that I can separate this by domain. And you can do this by user profile, and you can analyze who is spending what based off the resource tags that are automatically applied. Lastly, just want to call out that we've talked about experiments and model registries as well as training jobs being automatically tagged. But if you go and look at the actual instances that are backing these notebook kernels within SageMaker Studio, they also are sharing those automatic tagging capabilities. In this example, I'm going to look at the financial audit space and look at a kernel gateway that's running the actual notebooks that we were running earlier in this demonstration. We can see that the domain ARN as well as the space ARN are automatically attached. And if I were to do the same thing for a kernel app running in a personal studio, I can see that under Sean-users kernel gateways, the user profile ARN and domain ARN are automatically tagged. When it comes to restricting users from accessing resources outside of their particular domains, administrators can add a IAM policy which requires a certain string condition to be there when they're accessing a SageMaker resource. Whether they are updating or deleting that resource, it would be required that the SageMaker domain ARN is available for their specific line of business. I'm now happy to introduce Chitran Jain, engineering manager at Intuit, to talk about how these collaborative features are able to fit their future of machine learning environments and endeavors.
Thank you. Hello, everyone. And thank you so much, Sean. That was a great demo. So here I'm Chitrang. I'm part of Intuit, and I'm an engineering manager taking care of a lot of model development capabilities at Intuit. So let me talk a little bit about Intuit. So at Intuit, our mission is to power prosperity around the world. And we believe that with data science, artificial intelligence, and machine learning, we can make a real difference in getting there. Our goal is to help people around the world achieve financial freedom. We have an Intuit strategy that we want to be an AI-driven expert platform so that we can provide more money, no work, and complete confidence in all the financial decisions that our customers take. Today, most Americans live paycheck to paycheck with just a minor emergency away from a financial crisis. Half of the small businesses fail in the first 5 years. Unequal access to resources and opportunity makes it really hard for many to realize their dreams and achieve financial freedom. Our AI professionals work really hard every day to level the playing field. The tools that we provide help people make smarter financial decisions, deal with the unexpected, and gain control over their own prosperity. Let me present you with some data on how we are achieving our goals at scale. At Intuit, we have over 730 million AI-driven customer interactions per year. We do over 58 billion machine learning predictions every day. We record over 400,000 customer or financial attributes in our data lake per small business. To secure our IP, we have filed over 700 US patents. And we move about $113 billion of consumer tax refunds through our TurboTax platform, while we we manage about $2 trillion worth of invoices through our QuickBooks platforms. So let me talk about so in order for all of this to make happen, we really want to accelerate the AI development at Intuit. So as part of our ML platforms, tools, and strategy, and services that we enable for our AI developers, one of them is Intuit AI Studio. And Intuit AI Studio is a critical part of the model development lifecycle. And there are tools needed to explore, experiment, and iterate, and finalize the data and models for any given AI task before moving things to production. So there is a need for over 200 plus data scientists and machine learning engineers at Intuit to use notebooks on a daily basis to explore and experiment with data, train and tune their models, and come up with a model that is really viable for production. From there onwards, our production pipelines and production serving infrastructure helps them to deploy the model and serve inferences at scale. We are always aiming to provide an environment that is seamless for them across many technologies like Python, Scala, Spark, and deep learning workloads. So why AI Studio has chosen SageMaker Studio? So AWS SageMaker has been a trusted partner for Intuit since 2018. SageMaker Studio is a fully managed web-based IDE and a really good notebook solution. It provides seamless connectivity to our Intuit ecosystem, and it allows a lot of customizations. So for example, you can try different instance types. You can choose different kernels within SageMaker Studio. We have integrated our Intuit SSO to provide a seamless experience of logging in to a notebook. We have provided access to our Intuit data lake through SageMaker Studio. And we have connected our Intuit Enterprise GitHub for versioning and saving of notebooks. So in all, SageMaker Studio really helps to accelerate our overall model development lifecycle. So let me talk a little bit about how that setup looks like for us at Intuit. We currently have one domain that has all of our Intuit AI developers right now. And each of the developer, we give one profile so that they can go create multiple SageMaker resources like notebooks, run processing jobs, and whatnot. So here are some of the current challenges that we have in that space. So grouping things and users is always a current pain right now. Every data science team that we work with could be working on a variety of projects, whether it's NLP or regular ML-based projects. This is important, and it's really important as a company, as an enterprise, for us to separate people, data, code, and assets for organization and billing purposes. The notebook sharing and data sharing is not very ideal. In a hybrid environment today, if let's say I'm a senior data scientist, I want to collaborate with another senior data scientist on my team, I would have to probably go on a Zoom call or share my notebook through a Slack. And it does not happen anything in real time. You have to actually set up time and make that happen. And if I have a project that is already set up, if I have to set up that project locally or on my notebook, you can come across multiple versioning issues as well. And lastly, around tagging. Tagging has been a bit of a pain for us, as all the resources that get created for Intuit, we need to really map it and tag it back to a particular business entity, which is tiresome for a data scientist or does require a lot of custom tooling. So how these new features will really help Intuit? We are looking to expand the number of domains that we have, and we want to provide one domain for either one business unit or one particular data science team. And you can even have domains for different kind of security requirements that you may have if you're looking at a TurboTax data or if you're looking at QuickBooks data. We also want to provide what we call as AI project-based shared spaces. Each shared space could be for its own project. And we can have multiple project spaces per domain as multiple data science teams work on multiple projects at the same time. And we want to, the way that we look at it, we want to bootstrap the projects with GitHub repositories, users profiles, and provide them all these things together so that they can quickly go to a space and really get started. Sean gave a really good demo on the enhanced collaboration with real-time co-editing that's going to help a lot of our data scientists to work together. An automated resource and cost tagging for all resources per AI project would be very, very helpful for us. We'll be able to have all our internal billing and cost attribution set up so that we can determine cost versus benefit of each of our projects. Lastly, I just want to say, Intuit uses AI to solve our customers' most pressing problems and help them make insightful financial decisions. We automate, predict, and personalize their experience, help them make more money with less work, while giving them the confidence in their own actions and decisions. Our responsible AI principles guide us how we operate and scale AI-driven expert platform responsibly with our customers' best interest in mind. With all the Intuit AI tools and services, we want to be able to quickly iterate, train, and deploy models with fairness, accountability, explainability, and privacy. Even with the current scale of Intuit, AI at Intuit, we feel the journey of an AI-driven expert platform has just begun. So I'll now hand it over to Kunal. Thank you.
Awesome. Thanks, Chitrang. That was super insightful into seeing how Intuit is set up and how they plan to utilize these new capabilities in solving key problems that are specific to them. And all of these problems are personalized and specific to different enterprises, and we hope you guys can make use of these new capabilities as part of your own setup. With that, I would love to thank everyone for coming here and going through the different capabilities that we have built here, and appreciate Sean going through a really good demo to showcase the kind of capabilities that are there in the next-gen SageMaker, Amazon SageMaker notebooks. We saw today that you can utilize the ability to create and manage multiple domains so that you can isolate resources across these domains and set up your organizational structures as representing your different lines of businesses or teams as these different domains. We further also saw that you can utilize the automatic tagging that the service does to create these resource isolation boundaries and also utilize those tags to check cost and usage at various granular levels. Further, we also looked at how you can utilize shared spaces to collaborate across your teams and utilize this shared space to co-edit and co-execute code in real time, share files and different artifacts with different data scientists or builders that are working on the same business problem. With this, I'm super happy that all of you showed up and appreciate you taking the time. If there are any other questions or comments, we'd be around here for the next 15, 20 minutes if anyone has any other questions. Thank you, guys.